Well, I'm still continuing to rebuild this Yellowstone Park Stagecoach in the process of building the wheels. In the last couple of videos, I've been talking about the design of the spokes, how to create dish, and why it's there. Last week I started to assemble the spokes, and through the last few days I have been assembling the spokes into the other three wheels. So I do have those together finally. Over the years I have spent most of my time studying the vehicles themselves, and in the position that I'm in restorations mainly, I have studied a lot of different makers of vehicles, but I haven't spent a concerted amount of time learning about the history of the companies. That's something that just was out of my realm or scope of focus during my production working days. I was interested into the how-tos of the different makers. So in essence, I focused on the craftsmanship of the wagons, not so much about the history of the wagon companies. So in some regards, I get to learn now, as life is slowing down a little bit for me, more about the history of these companies. The company that built this Yellowstone Park Stagecoach was located in Concord, New Hampshire, the same company that built the Concord coach, what became more famously known for as the Wells Fargo Stagecoach. One was a wheelwright and the other was the coach builder, what we would call the wainwright. And through the course of their years, from the early 1820s to their last year of production of 1928, they built multiple passenger stagecoaches, of which the Yellowstone Park was one style. Well, through the last couple of videos, I've been bringing up the point that it was a mass production era of the transportation industry. I think Abbott and Downing at one time employed up to 300 people, if I remember that correctly. So they were cranking out a lot of vehicles as well, maybe not as many as some of the big high production companies were, but 300 men is not an insignificant company. Well, the process of turning these hubs and mortising and fitting these spokes went a lot faster than what I'm doing. But still, men were involved, and we find variations in the end product. And I have seen some of these changes even in the coaches that I have restored over the years, how things have progressed and different blacksmiths, different craftsmen have been at the task of building these coaches, because we all leave our signatures on the work that we do. That's because they were not operating with CNC machines or robotics. There were machines that were doing production in a mass scale, but they still had men involved. So there are variations. So even when I am cutting my mortises into the hubs, even though I have a machine that does it, I don't use a hammer and a chisel. I use a hollow chisel mortiser, but yet I am still involved in the placement of my bit. So even my mortises are not all exactly the same. So when I'm fitting spokes into the hub, I do take the time to measure each mortise and fit each tenon into that hub so that they all fit. That's just the personal man involvement in this process. And it was just as much then as it is today. So the next step for me is to cut the tenons on the end of these spokes and get ready to put the outside wood rims, or the felly or the fellow, on the spokes. Now I want a 42-inch OD in front and a 54-inch OD wheel in the rear. Now that is going to include a 1/2-inch tire. Normally wagon tires I would put 5/8 on, but these coaches seem to have a little lighter iron, so I'm going to put on only 1/2 inch thick. So if I remove that 1 inch for the tires, I want 41 in the front and 53 in the back. When I have looked at old literature, I see most of the machinery that did this process operated with the wheels laying flat or horizontal. And the tenoning auger would come in on each spoke. And I did that similar when I did the borax wagons, or you remember here more recently when I did the 10-foot tall Holt logging wheels. I laid that wheel flat and my auger came in horizontally and I cut those tenons. For most buggy and wagon and these Stagecoach wheels, I do it vertically. It doesn't take quite so much floor space for me to do it vertically as it does horizontal. These horizontal machines for cutting these spoke tenons just takes up much more floor space, which is kind of a premium for me. So the diameter of my hub is 6 3/4, and I want a 41-inch wheel on my wood for the front wheels. So 41 minus 6.75, 34 1/4, divide that in 2, 17 1/8 is what I want my spoke length to be to the outer edge of the spoke from the edge of the hub. So 17 1/8 length of my spoke, and then the thickness of my fellies are 2 1/4. So from that outer edge, I'm going to come back 2 1/4, and that'll be the length of my tenon. So this will be the OD of the felly, and this will be the ID of the felly. I just have to trim all these spokes off to length. And my rear wheels, I want those to be 53 minus 6 3/4 divided by 2. Those are going to be 23 1/8. And they'll still have 2 1/4 inch thick fellies on them. So before I change the height of my drill press here, I am going to take and cut the tenons on these rear wheels. So once I lower this head down, I won't have to lift it back up quite so high. I'm going to cut these tenons at 3/4 inch diameter. So there has been a few questions about how I know how to cut the tenons. So let's just pretend this is the dish face, and then the center is in the hub, and again a little bit exaggerated, but say my spokes are coming out at this type of an angle, and this is my dish. So if this was to simulate where the fellies are going to be, if I were to cut the tenons in line with the spoke, these tenons would be coming out at this spoke angle. In this case it's 1 degree. But these fellies need to sit square across the face of this dish. So in order to do that, these tenons have to be in line with this plane, not in line with the spokes. So that does create a spoke tenon change right at the fellies. It has to change right here. So as I mentioned earlier, most of the old timers did it horizontally. They would mount the hub on a pedestal, and then the auger would come in this direction, but that auger would cut that tenon straight across in line with the dish. This would be the framework of the machine that the wheel set on, and the auger came up and cut straight across. Well, I'm going to do the same thing. I'm just doing it vertically. So this back post of my drill press would be the framework that would have normally laid horizontally. I'm now setting it vertically, and this was the drive, even though it could have been hand powered, that would drive the auger. Well, I have just set it up this direction. Well, on the other side of the floor, if I sweep away my shavings here, you'll see that I have a mark painted on my floor right here. This is the same arc as my head would be if it were to travel on this post. This is directly in line opposite my chuck on my drill. So when I bring my wheel in underneath this drill press, I'm going to put my bottom spoke on that line, which is going to be directly underneath the center of this chuck. And so when I put this top spoke in my tenon auger, I have a straight line for this tenon to be in line with the tenon on the opposite spoke. Even though my dish, the angle of my spokes, sets my hub back, but my tenons are directly opposite. And that gives me the correct angle of the tenon to the spoke. And I tried to adjust that camera to where you can see the dish in the wheel, how it is still there, but I have a direct line across to the opposite spoke. So the principle is exactly the same when I do it vertically as the old machinery was designed to do horizontally. For me, it just takes less room. I would have to have, in this case, for a 50-inch wheel or for a Concord Stagecoach wheel that are 60 inches, I'd have to have a bed that was probably 80 inches to accommodate my chuck head and all that. Well, here I've got it within, this drill press is maybe 3 feet. It just stands tall instead of wide. So the positioning of that bottom spoke helps me to determine the angle of that tenon in this direction. And then when I'm sitting in my chair cutting this tenon, I take this body of the spoke and I line it up with the post of my drill press, and that's going to allow me to make sure that I have the correct angle this direction. So this way I do want it in line with the spoke, but this way I want it in line with the face of the dish. So when I'm starting to cut a new set of tenons and the blade in these tenon augers is adjustable, I do just a little bit of a cut, and then I'm going to drill, in this case, a 3/4 inch hole in a block and make sure that I have this size correctly. It doesn't take very much of an adjustment of this blade to affect this, so I always double check that first. Yeah, it was kind of dragging a little bit, if you could tell in the pitch of that drill. I'm a little bit big here, so I'm dragging on the side of my tenon cutter. I need to move this blade in just a little bit. If there's been one thing that has been most frustrating to all the guys that I've had help me through the years, it's the adjustment of this tenon auger. So I'm going to start a new tenon here. See how this one now works now. See, that's going to fit just right. It'll be snug, but that's exactly what we want. Don't want to be so tight that it would actually split the felly. We should be good to go. You could just hear how much easier this drill was running. Didn't have near the drag to it. So every time I'm checking my bottom spoke and I'm checking in line with my back post. So I think you can see how this tenon is straight across and how it has a different angle than this spoke as it's coming out of the hub. That's because, again, this is headed directly across to the opposite tenon. So you can see that's the whole purpose of putting these cones on as the first step. It helps that point of that cone set up into the appropriate hole, in this case, a 3/4 inch tenon. now I'm going to take that same board that we checked for dish and run it across two opposite spokes as close as we can get. The hub is in the way to go exactly opposite. But we can see now, if we look at both ends of the tenons, how the tenons are in line with the line of our dish, not in line with the line of the spoke. And on the opposite side, we have the same effect. We're parallel here with the dish, but not with the spoke. So now our fellies can go on in a flat plane, whereas if these tenons were straight with the spoke, we would have to drill angled holes into the fellies to accommodate that angle of the spoke. This is just how it works, to where the fellies can sit on a flat plane because all these tenons are now on a flat plane, but all the spokes are coming out at an angle. So for some of you, this is just all review. For some of you, it's new ground. Hopefully it'll make sense though. If you have any questions, leave it in the comment section. My wife Diane reads every single one of those, and when there's questions that come up that she can't address, she fields them off of me. Anyway, appreciate you coming along. Thanks for watching.